This video is the first in a series on Markov chains. I'm going to start with an example just to show you what the general idea is, and then we'll talk about a definition for Markov chains and stuff like that in the next video. So in this video I'm going to start with this example. I'm going to look at how voters change party from one election to the next. So I'm going to assume we want to follow how a voter votes from one election to the next. Assume that there are two parties, just to simplify things, since this is our first example. You could either vote Conservatives or Liberals. I have a diagram here that we assume explains how a voter change from one election to the next. So just to make sure the diagram is clear, let's start with an example that's just about reading it. If a voter votes Conservative one election, then what are the odds that he will vote Liberal in the next one? Alright, so in this diagram, the circle represents what the elector is doing now, and the arrows tell you how it's going to change. So if a voter votes Conservative, that means he's here. And now we want to know what are the odds that next election he's going to end up here. Well, there's an arrow here that tells you that 10% of Conservatives end up going to the Liberals in the next one. So that probability is 10%. All right, so what if a voter votes Liberal this election? Now, I want to know what are the odds that he votes Conservative at different elections down the road. So what are the odds Alright, so we vote Conservatives next election. Alright, so he's right here. I want to know what are the odds that he ends up here next election. Well, that's what this arrow tells us. It tells us that 15% of the people that are here in one election will end up Conservative the next one. But what if I ask you not about the next election, but about the one right after that? So let me leave the diagram since that's really the key here. What if we want to know in two elections? So let's call the with today's election, I'm going to call it Liberal 0. So he's voting Liberals now. Now in the next election, two things could happen. You could vote Liberals, or you could vote Conservatives. And we have the odds of that. 15%, that's what we just found out here. We have 15% here. We have 85% here. And now, from these two, we again branched out. In the second election, he could stay Liberal, go Conservative, and in this case, he could move back to the Liberals or stay Conservative. So we want to know the odds that he's in the Conservative part, so we want to know the odds that he's here or here. So let me add the weights to these two as well. So if he's in the Liberals, there's still an 85% chance that he stays here, and there's a 15% chance that he moves there. Now once he's Conservative, those odds are different. Here it's a 90%, and here that's a 10%. Alright, so my probability comes from two different branches in this tree. I'm going to look at both this path. So he'd be Liberal, Liberal, and then only Conservative. And then this path. Liberal, move Conservative right away, and then stay Conservative. So my probability will be made up of two different things. Would be the probability of L1 and C2 plus the probability of C1 and C2. Now whenever you have an and in a probability like that, that means you need to multiply the two. Whenever you have an or, that means a sum right here. So I could go this way or this way, but I must take both. So this and this, or this and this. So here, I'm going to take the 85%, which I'll write as 0.85 times 0.15. And then I have 0.15 times 0.9. And I have computed it. And that's 26.25%. So if we believe our diagram, then the odds of ending up Conservative in two elections for a Liberal voter would be about 1 in 4. Now I want to show you how to make this computation and put all the information of the graph inside linear algebra. So let's redo this. Alright, so I'm going to put all of my starting probability in a 2 by 2 matrices. So each column would correspond to a party, and each row will also correspond to a party. So the one important thing to remember is this here will correspond to the current state of things, the people you're voting for right now. So, party for this election. And in green, that will be the party for the next election. So if you remember, if you were Liberal, you had 85% chance of staying Liberal in the next election. So if you're Liberal this election, you have an 85% chance of being Liberal in the next one. If you're Liberal, you have a 15% chance of ending up Conservative the next time around. And so that first column tells you all the odds of somebody that's currently Liberal where they'll vote next election. Now the second column will give you all of the probability for somebody that's currently Conservative where they will end up. So we said 10% and 90%. So a Conservative voter this election has a 10% probability of ending up Liberal in the next. All right, so now what I'm going to take, I'm going to make what the current state is a vector. So this election, we're told that our voter is Liberal, and so I'm going to put this will be the probability of Liberal, and this will be the probability of Conservative. So right now he's Liberal, so 100% Liberal, 0% Conservative. All right, so that's the current state. So I'm going to call it X0. So X, let me put the 0 up. That's quite common. So I'm going to use this as the current state. And to figure out the next state, what the odds of our voter voting Liberal or voting Conservative, I'm going to multiply by P. So X1 will be next election. And I claim that that will be P times X0. So let's try it. I will have 85, 01, 015, 090 times 10, and that's going to give us 85% of being Liberal and 15 of being Conservative. So that corresponds to this level of our tree, 85% on the Liberal side, 15% on the Conservative side. That's what this vector tells us. Now, if I want to know 2 elections from then, I need to take X2. So let me erase the part we've done. So I'm going to look at X2. And I'm going to get P times X1. I'm going to reapply the diagram again to my vector that represents a mixed state. I'm partly Liberal, partly Conservative, because we don't know yet which of the 2 branches I'll take. So that's going to be, sorry, let me erase this. be my same matrix because the diagram hasn't changed. It's just that instead of starting at 1, 0, I'm starting at 85, 15. Not quite sure where I am, but I have odds of being in each. Now I'm going to multiply this, and let me leave the long, before we add it up, let me leave the long computation. So I'm going to get 0.85 times 0.85. Here I'm going to get 0.1 times 0.15. This one is 0.15 times 0.85 plus 0.9 times 0.15. We have two different items here, and that represents the two different ways that we could end up liberal in two elections. The first way is we're liberal, liberal, liberal. So every time we have an 85% chance of staying liberal, so 85 for the first, 85 for the second, those are the odds of having liberal, liberal. And then this one is you have liberal at 0, you move conservative, and you move back to liberal. So 15% chance of moving to the conservative, and then 10% chance of coming back. This computation we already have on the board. These are the odds of having liberal first and conservative second. This is exactly what we did here. This one is conservative, conservative. So 15% chance of moving from liberal to conservative, and then 90% chance of staying there. And so second is 26.25%, so let me write it in decimal form. I find that's more helpful. You could compute the first, but once I know I have 26.25% chance of being conservative, then everything else is liberal. So that will be 75, 3, 7. Let me double check, but 73.75. Yeah. So at this point, I know the odds of being liberal in two elections, I know the odds of being conservative. So 73.75% chance of being liberal. Let me write it in words. And I guess there is a 73.70 chance, and there is a 26.25% chance of being conservative in two elections. So now we've seen how linear algebra can help. It can help keep track of all these probabilities, and you can assume that if I'm looking at what's going on in 10 elections from now, I don't want to have to do a probability tree with 10 different heights, 10 different levels, and 2 in each, so 2 to the 10, a huge number of leaves at the bottom. That'd be crazy and would take a long time. This is nice, it's just algebraic, I just take powers of matrices. Now, taking powers of matrices is something that we're getting good at, so we'll see in a couple of videos how to use diagonalization of matrices to make these computations nicely and to predict long-term behavior as well.